What is up, Flutter devs? Today, in our continued port of processing to Flutter, we're going to implement the final procedure remaining for 2D primitive shapes, and that is the arc procedure, which draws an arc, possibly with a fill, possibly with a closed stroke. Let's go look at some screenshots and you'll see what I mean. Here we are with the standard processing spec, and you'll see these visual examples here. You can see that we have a number of different visual representations using this arc procedure. Let's talk a little bit about what we're seeing in front of us and then figure out how we're going to implement it. This first visual example kind of does a little bit of everything, so let's put that to the side. Really, the following three examples represent all of the real variations. What drawing an arc comes down to, based on what we're seeing here, is a question of two things. I mean, obviously there is the arc itself, which is, you can think of it as a portion of the exterior of an ellipse. That's involved with all of the examples that you see. But in terms of the differences between the ways we might draw an arc, there is a situation where the ends of the arc are connected directly together, but that connection is not stroked, it is only filled. Then there's the exact same thing, except the connection between the endpoints is also stroked, so the entire shape has a stroke and a fill. And then finally, kind of a Pac-Man style actual pie chart looking circle segment is, I think, the technical term, a circle segment. In this case, at the endpoints of the arc, lines are drawn back to the center of the ellipse, and then the whole thing in this case gets a stroke and a fill. I think if we can draw these three variations, we have implemented the processing notion of an arc, and each of these are differentiated with this final parameter that you see in these examples. The first being open. Open means we still have a fill, but the endpoints of the arc are not connected with a stroke. Then there's chord, which means that the endpoints are connected. I guess maybe that's what they mean by a chord, is you connect them with a chord. Otherwise I don't know what that means. And then there's pi, which is a pretty natural term for what we're looking at, which looks like a portion of a pie or a pie chart. The interesting thing here from a Flutter perspective is that we do have a couple of methods that are quite similar to this in Flutter, but they're not quite the same, and so I'm not sure what we're going to get. One of them is draw arc. It takes in a rectangle, which if you watch the last video, in the last video we implemented ellipse, and we talked about how an ellipse is fully defined by a rectangle, so that makes sense. Then we take a start angle and a sweep angle. This is very similar to how processing does it, except processing takes a start angle and an end angle. So literally the specific angle where you begin and the specific angle where you end, whereas Flutter says, give us the start angle, but then tell us like how many radians to sweep. This use center property here, if this is true, then the endpoints of the arc are going to draw lines back to the center, meaning that when use center is true, we get the pi representation. So the pi representation, that should be no problem. The place where it's interesting is these two up above. Getting the chord shouldn't be a problem, I don't think. Because I think if we use draw arc and we say use center false, I think what we're going to get is the chord, where it strokes the whole shape and fills it, and then we're good to go. The question is, what happens when we want to draw it open? What happens when all we want to do is stroke the arc itself and not the chord in between? It's possible that this can't be done with draw arc, in which case maybe we have to go over to this arc2 method. Maybe arc2 doesn't quite do it. we'll see what we get, but that's the question. That's what I'm wondering as I'm looking at this is can we really get all three of these with the same canvas method? Up here back in the first example, there's not really anything more complicated going on here. It's just that there are 4 different arcs being drawn and one of them has a fill, but the other 3 do not have a fill. Besides that, they operate the same way as the other examples that we're looking at. As always with our procedure, we're going to first define, in this case, 4 tests to replicate what we see here, and then we're going to try to implement arc to actually draw what we see here. Back here in our test suite, let's come to the end here. Let's grab this final test. We'll copy and paste it and then update it accordingly. This is arc example 1. And we're going to change the golden file name to example 1. Oops, arc example 1. I'm going to erase this implementation for now, and we will come back to this. And then I'm going to copy and paste for the other 3 tests so that we have tests ready to go and fill with the details. This is example 2. This is example 3. And then finally, example 4. The implementation does not yet exist to draw an arc, so we are going to kind of design it as we go. Here is the first test that we want to write. We'll copy this as a reference and see what makes sense. We know we're going to want to invoke multiple methods on Sketch, so we're going to use the cascade operator. We want some kind of method called arc, and the question is, what do we need to pass in? The first 4 parameters to arc are the exact same parameters that we would give to ellipse. Let's look back up at ellipse for a moment. Here's how we drew an ellipse. We passed in an ellipse data structure. So we might as well pass in another ellipse data structure. That is how we are representing ellipses in the Flutter port of processing. Therefore, we will pass in an ellipse. Now let me go see what form this is using. So 50, 55. I believe the form this is using, this is the X and Y of the center of the ellipse, followed by the width and the height. Not the radius, the width and the height, I believe. Although, no, I think that's right. That's right. Because 80 would be the largest one here. That looks about right. We want ellipse from center. The center in this case is 50, 55. The width is 50. The height is 50. We're going to go with named parameters here because the next 2 parameters are both doubles and they're both angles. So I want to make it really clear what they mean. Therefore, this first thing is just going to be called ellipse. Then we're going to say start angle. Then we're going to say end angle. There will be a 4th optional parameter, which is I'm not sure what they call it. Let's see what they call that thing. So this final parameter is what I'm talking about. Let's see what they call it. There are 3 ways to draw an arc. The 3 options. I'm not seeing a name for this. It seems to just be referred to as an optional 7th parameter. I don't know. I'll think about it. We'll define that when we have to. But there will be one more parameter, which is that mode, which is not needed at the moment. Again, implementing the specific example from the spec. For this first arc, the start angle is 0. The end angle is pi over 2. And then that's it. Then we're going to say no fill. And then we want 3 more arcs. This next one is still, all of these have the same center position, and their radius or their width and height grow by 10 each time. And the start angle for this next one is pi over 2, and the end angle is pi. The third one has a width and a height of 70, and its starting angle is pi. Its ending angle is pi plus pi over 4, apparently. And finally, we have one with a width and a height of 80. Its beginning angle is pi plus pi over 4, and its end angle is 2 times pi. That is the first example, and then there are 3 more. The others just have 1 arc, so we'll just copy this down and then adjust. Here's what we want. Center is 50, 50 this time. The width is 80. The height is 80. The start angle is 0. The end angle is pi plus pi over 4. This time we do need the final parameter. Let's refer to it in terms of the parameter name is mode, and then this mode should be an enumeration. Let's call it arc mode for lack of a better term, and we will say open. Now let's go down to test number 3. We want this one right here. It's going to be the same ellipse and the same angle, but it's going to be chord instead of open. And then we can copy that down to the final test, which everything here is the same except it's pi instead of chord. We now need to implement the code that provides this API. Okay, over to the place where we have implemented all other such APIs. First, let's define that arc mode enumeration down here at the bottom. Let's say enum arc mode, what was it? Open, chord, and pi, save. And then let's see, where in this list would it make the most sense to offer an arc? I'm going to guess after ellipse seems like a reasonable place. Arc, and we said that we're taking an ellipse, which is required, and we are taking in a start angle, which is required. We take an end angle, which is required, and then there is an optional arc mode, which is going to default to arc mode.open, because when it's not provided, the behavior that we want is the open mode, I believe. Let me verify that again. By default, what do we get? So look at this guy right here. It's drawn with this arc up here. There is no mode being provided, and you can see that it is left open. So open is the default. Now we need to somehow implement this. If we look back here, all of the red squigglies are gone so that we have the API declared as we want. We just have to figure out how to draw these things. just to get us started, let's just start taking baby steps through this. The simplest way to take baby steps is to begin by switching on the mode, because the arc mode, the different arc modes are going to create, like we have all the reason to believe that pi is going to work just fine. It's these other arc modes we're not sure about. Now, maybe after we implement all 3 arc modes, we'll realize that most of what they do is the same, and then we can refactor. But for now, I want to be able to start with the part that I know is going to work and then focus on the parts that I'm not so sure about. So in arcmode.py, this is the scenario here where it looks like a pie chart with a stroke. We'll say canvas, draw arc. The rectangle will be ellipse.rect. The start angle is already passed in. The sweep angle is end angle minus start angle. I actually don't know if that's always going to be the case. The examples that we're given here are all pretty straightforward. One thing that I'm wondering is what happens when you pass in negative angles. I'm not going to worry about it because these examples don't worry about it, but it's very possible that what I do here doesn't really work when you start doing interesting things with the angles you pass in. Use center, because this is the pi mode, we want it to be true. And then paint, we actually have to draw twice as usual. So let me copy this. Save, and now we draw twice, one for the fill and one for the stroke. If there is no fill, then this first one will just be invisible as if it's not there. This implementation, I think should be enough to give us what we want. Now let's see what we can do about these other ones. Let me copy this up to chord. And let me try, well, actually, neither of these should have use center as true. I think by simply changing use center to false, I think this gives us what we want for chord. What I'm not clear about is how to get open. But before we go further, and I'm just going to copy that directly up to open. So right now these two are the same, and I know that. But let's just see if we run the tests with this implementation, what does it actually look like? So Flutter test update Golden's plain name equals arc. All right. And where are the arc Goldens? Wonder if my file system is it's not updating here for some reason. Yeah, there's the files. They're not showing up. They're not showing up in the IDE for some reason. Oh, there they are. Okay, let's start with the number 4 should be the pi. This one should be the one that works. Okay. Again, weird stuff with how these lines are drawn. I don't know what the deal is with that, but that is what we expected for this pie chart looking thing, right? So that's what we expected. Okay, then 3. Okay, so interesting. I thought, so the one that I just opened up should be the chord, but notice that it's not connected. What this means is that when we stroke a draw arc, it doesn't close the path. The open implementation is actually correct then. So I'll go to the second one here. This is correct for open. This is what we want for open, right? So that one's good. The pi is good. Open is good. Chord we need to figure out. Now let's see what this first one looks like. Okay, so the first one, interesting. And actually, at the moment, I'm not sure why open looks this way. Let's go read what it says about open. It draws an arc to the screen. Arcs are drawn along the outer edge of an ellipse. The origin of the arc's ellipse may be changed with the ellipse mode. Start and stop. Yeah. The rendering technique. Oh. Okay, so the default mode is open stroke with a pi fill. That's interesting. That's interesting because the default rendering, the default shape, is impossible to explicitly specify. So what it's saying is the stroke is open, meaning the stroke is just the outside of the arc like this, but the fill, the color inside the shape, is pi. Which means that the default is none of the actual values. The default is not pi or open or chord. There's a special mode, which is default. Okay. Well, one issue at a time. Let's go deal with this default situation. What that means is that arc mode actually has a default mode. Ideally, I would call it default, but that's a reserved word in the language used in switch statements, so I will call it default mode. That also means that the default value for mode is not open, it is default mode. Or, to make this totally explicit, let's call this, what was it? It was open stroke pi fill. Technically, by exposing this enum value, we are giving users of our package more control than they have in regular processing, but I don't see any reason to hide this. I think it was a really poor idea for processing to have this secret default value, which does not correspond to any of the three possible values that you might pass in. Doesn't really make any sense to me. In the case of this default, what do we want to do? Let's copy the pi example. We want a pi fill, but an open stroke. Here's the fill. Here's the use center variable. So we have a pi fill. Let's switch this one to false for the stroke. All right. I think this will fix at least the first test. As a reminder, this is what we're looking for right here in the first test. And there it is. We have the pi fill, the slice of pie, and then the stroke is kind of just the crust of the pie, so to speak. Result number 1 is what we want. Result number 4 is what we want. Result number 2 is what we want, but result number 3 is a problem. The question is, how do we get a stroke in that final segment from end to end? It may not be possible with draw arc. Let me see if path has a draw arc on it. It has add arc. I think what we're going to have to do is use a path, add the arc to the path, and then close the path. We can do that with a path. I don't think we can do it with a canvas. And we want to do this for chord. And so chord, the fill is fine. What we want to do instead of the stroke, we want to say draw path, and then we want to pass in the chord path, which doesn't exist yet, and then we'll use the stroke paint. We want to define a chord path, which is a path. Now, I don't know, when we add an arc, actually well, we can try it, but the fact that we're adding an arc, I don't know what that does, if anything, to the current position of the path. We shall experiment. With add arc, the arc that we want is on the path. I don't know if the original point on the path has any impact on this arc, and I don't know where the current drawing path is at the end of the arc, but if we're lucky, we can just close the path and it will draw a line right back to the start of the arc, if we're lucky. Let's see what happens. We'll save that and we will rerun the tests. And this third, example 3, is the one that we're looking at. Hey, it worked. Amazing. So example 1, example 2, example 3, example 4. And again, a quick recap of what we did here. The fill was always fine. We didn't change the draw arc call for the fill. But with the path, we told the path, add an arc around this ellipse. So I think what the path did is the path started right here at this point at the 0 degree mark. It swept all along this arc, and then the drawing position, a path always has a current drawing position. I believe that current drawing position was left right here at the end of the arc. And then we said close path, which takes the final drawing position in the path and connects it back to the very first drawing position in the path, which was the beginning of the arc, which gives us the stroke around the shape. That means that we have now implemented the arc method, which corresponds to the arc procedure and processing, and that now completes everything within the 2D primitives. So we have now completed one section of one column of the API surface for processing. I think in the next video, I will walk through the 2 or 3 steps necessary to actually push an update of this package to PubDev. Not that I expect anybody to use it with just 2D primitives, but we can kind of say, like, we've finished a piece, so let's ship it. And then we'll finish another piece and ship it. And we'll just keep shipping this thing to PubDev as we go. And it's just following a process over and over again. So in the next video, we will release an update. And then after that, it's time to pick some entirely new section here. I think maybe it's time to deal with the fundamentals of animation, which really just means drawing one frame after another. We'll see. We'll see what looks like the most appropriate place to go next. But in the next video, we'll release an update, and then we'll take it from there.